Hello! Today we're going to talk about concentrations. Basically, there's two different ways of measuring a solution's concentration. We could do it either by molarity or by parts per million. Now, the one that is a little bit more self-explanatory is parts per million, and the way they write parts per million is ppm. So, parts per million would be like having 1 million water molecules, which I'm going to draw out, boom, 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 boom. You get the picture. We have 1 million of these times 1 million. And, for example, 7 parts per million would be 1, 2, 3, 4, 5, 6, 7 parts of something, like sodium chloride, carbon dioxide, whatever, in the water. Now when we're talking, another way we can do it is we can talk about molarity. And molarity simply means moles per liter, and the liter of solution. Okay, so we have parts per million, we have molarity. What are we going to do about this? First, get out your reference tables. Okay, now that you got your reference tables, we're going to look at a question. How much CO2 is dissolved in 850 grams of water to make a 7 ppm CO2 concentration? Before we start, we're going to start annotating our question. First of all, if you look at the equation, it is grams, sorry, it's written mass. Sorry, mass of solute over mass of solution times 1 million, that's ppm equals. So what we have here is we're going to have to start annotating this and substituting in the parts that we need. So we have basically if we look at this question, how much CO2 is dissolved in 850 grams of water? We have to figure out what is the solute and what is the solution. So go ahead and look right here. Which one is being dissolved? That is the solute. CO2 is your unknown. So already I can start writing my equation equals X, mass of the solute, which is the CO2. Now the solution, that's the entire encompassing material, contains 850 grams, so that would be the solution. So I'm going to put an 850 right here. And the last part, the other number we have, is a 7 ppm CO2 concentration. That right there is, I know, shocker, right? 7 ppm. So 7 equals X over 850. Now, I'm going to put this over 1. We're going to cross multiply and divide. Let me get out my calculator. I'm using my app. Okay, so where is it? Sorry, you're looking for a calculator as well. Maybe you can figure it out faster than me. 850 times 7 equals 5,950. But notice up here, I'm multiplying by 1 million. So in order to solve for this, I need to figure out the parts. So it's 5,950 parts. However, that's in 1 million. So I'm going to need to divide my final answer by 1 million. So divide by 1 million. And the answer is, now I'm not paying attention to significant figures, so don't freak out, but it is 0.00595. Now this is in grams, so this one also has to be in grams. But I don't really want to measure something like that. In fact, who knows what 0.00595 grams is? So we can convert it to milligrams simply by moving the decimal place over 3 places. 1, 2, 3. because 1 milligram is 1/1000th of a gram. So it would be 5.95 milligrams of CO2 or 0.00595 grams of CO2. Okay, now we have another type of question using the molarity, is how many grams of hydrogen fluoride, the solid, are required to make 6 liters of a 2 molar hydrogen fluoride aqueous solution. Got a lot of information in this question, and I actually like these questions better than the parts per million question because honestly they're a little bit more fun to solve, and sometimes they require a little bit more thinking. So first of all, we're going to look right here, and we see, to determine whether it's a parts per million or a molarity question, we first have to start identifying stuff. So 2.0 M, what the heck does that big capital M mean? Well, if you look right here in table D says molarity for capital M, and it is solution concentration. I'm going to go ahead right there and just write molarity. Right here we got how many grams? Okay. Well, first of all, I know that grams is a measure of mass. And the other piece of information that I have is 6.0 liters. Well, 6.0 is the number of liters which measures volume. So I'm going to look mass, volume, and molarity. First of all, if I see molarity, pretty much it is only one of 2 questions, and we haven't even learned one of the types of calculations that we're going to need. So we know right now it's molarity. So the formula for molarity equals moles per liter. However, we have the molarity, we have the moles. No, we don't. We have the liters. Yes, we do. So let's go ahead and write down the information that we do know. Molarity, 2.0. Molarity. Equals moles, grams. Whoops, that's a mass. We need moles. We'll come back to that later. Equals X over 6.0, which is the amount of liters. Okay? Now, this X is going to calculate the amount of moles, not grams, moles. This is a challenge question. We have to do 2 steps. So 2 over X, 2 over 1 equals 6 over X. 2 over 12 equals, 2 over 1 equals 12 over 6. That's X equals 12. I'm not a math teacher. Okay? So we need 12 moles. It's asking us for grams. We're not done. Okay? Now we have moles. We need to convert that into grams. So we need to find out how do we convert it from moles to grams. Guess where we look? Table T. We're going to be using table T a lot. So get used to it. We're going to look for mole calculations. Moles equals given over gram formula mass. Now, I know right here that the number of moles is 12 because I just told you that. Now, I don't know my given mass. And if we look back to our original questions, it's saying how many grams. So I'm going to go ahead and put an X there because we can always determine what the gram formula mass is. I have hydrogen, I have fluorine. Hydrogen, I have 1, and each hydrogen is 1, so that's 1. Fluorine, double check. Fluorine, I have 1, and that mass is 19, so that equals 19. The mass of hydrogen fluoride is 20. So we have 20 grams of hydrogen fluoride that are in 20 gram formula mass here. So we put the 20 here on the bottom, because that is the gram formula mass. So 20 over 1 equals x over 20. Cross multiply. X equals 240 grams of HF solid. That's the answer. Now what I want to see you do. Practice. 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 We're going to spend a lot of time on this. You're going to have to be experts in this. Do the practice problems or you don't get credit. Okay? Peace out.